Hello and welcome. In this video, we want to do a question related to the definition of derivative and the tangent line. If f of x equals 2x over 1 plus x to the 2, find f prime of 1 and then use it to find the equation of tangent line to the curve y equals 2x over 1 plus x to the 2 at the point 1, 1. Attention, in this video, for finding f prime of 1, we are not going to use derivative rules. If you want, simply you can use quotient rule to find derivative of this function. But here in this video, for finding f prime of 1, we want to use definition of derivative. So we are asked to find f prime of 1 using definition of derivative. So we are not allowed to use derivative rules like quotient rule. Otherwise, using quotient rule is simply we can find the slope or derivative of this given function. For finding f prime of 1 or f prime of a in general, we have two formulas. F prime of a equals limit of f of x minus f of a over x minus a as x approaches a. Also, for finding f prime of a, we can use this formula, limit of f of a plus h minus f of a all over h as h approaches 0. For this question, for finding f prime of 1, I am going to use this formula. If you want, you can use the other formula for finding f prime of 1. F prime of 1 equals to limit of f of x minus f of 1 over x minus 1 as x approaches 1. F of x is the given function 2x over 1 plus x to the 2. F of 1, for finding f of 1, simply you have to plug in 1 in numerator and 1 in denominator for x. Numerator is 2 and denominator is 2 if you plug in 1 for x, so 2 over 2 is 1. So f of 1 equals 1 all over x minus 1 as x approaches 1. Attention to this given point. When x is 1 in this function, the y value corresponding to that x value is 1 also. So basically we didn't need to find f of 1 from the function. It's already given by this point. We know that this point lies on this function. So when x is 1, f of 1 or y value corresponding to that is also 1. Let's find this limit. 2x over 1 plus x to the 2 minus 1 over x minus 1. For finding this limit, you have to try to simplify numerator. And to simplify numerator, you can think to doing a common denominator between 2x over 1 plus x to the 2 minus 1. And you can simplify with doing a common denominator. But the better way, instead of doing a common denominator, is to get rid of the denominator if we can. And by multiplying the numerator and the denominator by 1 plus x to the 2, we can get rid of the denominators. So instead of doing a common denominator, this is the easier way to simplify the numerator. We are going to multiply numerator and denominator by 1 plus x to the 2. And the reason that you have to multiply also the denominator is that if you just multiply the numerator by something and you don't multiply the same thing by the denominator, you change the limit, you change the expression. So only you are allowed to do this if you multiply numerator and denominator by same thing. Now, if we multiply this in the first expression here, 1 plus x to the 2 and 1 plus x to the 2 from denominator, they cancel each other, and so we get limit of 2x minus 1 times 1 plus x, so minus 1 plus x to the 2. We have this, and denominator is x minus 1 times 1 plus x to the 2 when x approaches 1. Now if we simplify numerator, we can write it as negative 1 plus 2x negative x2. It's better to write negative x2 first. Negative x2 plus 2x minus 1 all over x minus 1 times 1 plus x2 as x approaches 1. Attention, this negative is for all of these brackets, so basically we have negative 1 and negative x2. So we got this in numerator. Now if you look at the numerator, the coefficient of x to the 2 is negative, so and we want to factor the numerators. The first thing I am going to do is to plot that negative. If we factor a negative from numerator, we have x to the 2 minus 2x plus 1, and denominator we have x minus 1 times 1 plus x to the 2 as x approaches 1. Here you have a quadratic expression. For that quadratic expression, we look for two numbers that their product, when we times them, it's 1, and their sum is negative 2. Those numbers are negative 1 and negative 1. So we can factor the numerator like this. And if we write the denominator, x minus 1 times 1 plus x to the 2, x minus 1 from numerator with x minus 1 from denominator cancels, and then we have limit of negative x minus 1 over 1 plus x to the 2 as x approaches 1. If you plug in 1 to find the limit, numerator is 0, denominator is 1 plus 1, 2, 0 over 2 is 0. So f prime of 1 equals 0. So from our calculation, we got this f prime of 1 equals 0. And remember, derivative shows a slope of tangent line or a slope of the curve. In the second part of the question, we are asked to find equation of tangent line to the curve at the point 1, 1. For finding equation of tangent line when x is 1, we need to know a slope of the curve at 1, and here we have a slope, derivative of the curve, derivative of the function at 1. So everything is ready to write the equation of tangent line. Let me remind you, equation of a line in the point slope form. The given point is 1, 1. The slope is 0. So the equation would be y minus 1 equals a slope 0 times x minus 1. 0 times the bracket is 0, so y minus 1 would be equal to 0, so y equals 1. Because the slope of tangent line is 0, the tangent line is a horizontal line. As you can see, y equals 1 is a horizontal line, and so the tangent line is a horizontal line and its slope is 0. Before I finish this video, let me graph this function, this given function, and its tangent line, so we can understand better what happened here. The graph of the function f of x equals 2x over 1 plus x to the 2 is something like this. You don't need to know the graph of this function at this moment. I'm graphing it here to see the function and its tangent line. We are asked to find the tangent line at the point 1, 1. As you can see here, the graph of this function at the point 1 has a maximum value. And so when we draw the tangent line at this point, if we draw the tangent line, as you can see, the tangent line is horizontal. And what is the equation of this horizontal line? Y equals 1. I hope you liked this video, and see you in the next videos.